All right, folks, it's Bass Action, back in action here. In this video, we are going to go through some more algebra skills. We're going to go through factoring, solving equations that have fractions in them, and also solving systems of equations. Just like before, you can see that I have everything already worked out here. So you're likely going to need to pause this video if you're trying to write everything down. And then also keep in mind that I've got plenty of practice if you are stuck on any of the areas. All right, the first one that we're going to look at is simple solving by factoring. Now, we reviewed factoring on the previous video, and in these problems, we're going to actually solve by factoring. So instead of stopping with the factored expression, we are going to actually solve the equation. So taking a look at this first one that I've got up here, this example 5a, we know that this is going to be a quadratic that we're going to need to solve with some factoring because we see this x squared term here. Now, we're going to have other methods that we could solve quadratics from your algebra days, but the ones that we're going to focus on in geometry are generally going to factor. So if you see an x squared, what I want you to do is make sure that you get everything over to one side, writing it in this descending order, the x squared, the linear term, and the constant, and make sure that you set it equal to 0 and you don't lose that equation, that equal sign. Lots of students miss that, and then they don't quite get the right answer. The next thing you're going to do is we're going to factor this. It's going to factor into an x plus 8 and an x minus 5. That should be pretty easy. Again, we reviewed that in the previous video. And then what we're going to do is we're going to use what's called the zero product property, and we're going to take each of these factors and we set them equal to 0. Now, we can do this generally just in our head, but I'll write it down here for you. What we're doing is we're saying x plus 8 equals 0, and we're saying x minus 5 equals 0. And we're mentally solving each of those little equations to come up with our two x values, being negative 8 and 5. The next problem is going to work the same way. Again, as soon as I see that I have an x squared term, I'm going to take everything that I have and I'm going to move it over to one side. Now, it doesn't have to go to the left. I generally just like to keep my squared term positive. So again, I moved everything over. That got me a 5x squared, a positive 12x after I subtracted the 2x, and a positive 4. Notice I still have it equal to 0. Then I followed my split the middle method that I used in the previous video to factor this. So I said my 5 times my 4 gave me a multiply to 20 and add to 12. I went through my factoring process here and I got my two factors, still equal to 0. Then, just like in the previous example, I mentally set this equal to 0, and that gave me a negative 2 when I solved the equation. And I mentally set this equal to 0, although you're welcome to write it down, and I solved it, and I got a negative 2/5. Now, the next thing that we're going to do is we're going to look at solving equations with fractions. I see a lot of students try to actually work with all of these fractions, and you'll hear me say often that the best way to deal with your fractions is to make them go away. So we want to get in the habit of regularly clearing these by multiplying by the LCD, the least common denominator. We're going to multiply through by that least common denominator so that we don't have to work with the fractions. Our answer might still be a fraction, but our work along the way is going to be easier. So what we're looking at here is we're focusing on these denominators, this 2 and this 4, and we're looking for what is the smallest number that both 2 and 4 divide into without a remainder. That's going to be our least common denominator. And then we're going to multiply the entire equation, both sides, by this 4. Now, I like to do some work in my head, so I'm kind of focusing on this part right here, and I'm thinking of 4 times the 3 halves. I know that 2 divides into 4 2 times, and 2 times 3 is going to give me a 6, so I get my 6x. This doesn't have anything to cancel, so I just have my 4 times 2 is my 8. And then I'm taking my 4 times this 5/4. Of course, 4 goes into 4 once, so these are going to cancel, and I'm left with just the 5x. Nothing here. 4 times 6 is 24, and then I can just solve my equation, and I get x equals 16. Much easier than trying to add and subtract fractions. We're going to do another one of these. Now, if the handout that you have doesn't have 2/3 here. If yours has that typo that this originally had, make sure you fix that so it's 2/3 x. So this is what our whole equation should look like. We are going to multiply this by a 3. Notice I wrote the 3 on the right hand side this time. It's no big deal. You can write it wherever you want. We're going to distribute this. My 3's are going to cancel and I'm going to be left with the 2x. My 3's are going to cancel. I'm going to be left with 16. There's nothing to cancel here, so I just have to distribute. Minus 6x minus 6. Then when I solve my equation, I moved my 6x over here, moved my 16 over here. Notice when I divide this through, I have this fraction, and then I just reduce it, okay? But notice that even though we ended up with a fractional answer, our work in the middle was much, much easier. Now, my solving systems of equations, we're going to look at some more fractions here so that we can review that skill a little bit more in case that was a little challenging for you. And when we look at solving systems of equations, you'll notice I made these two sets of systems of equations pretty complicated looking. All right. Now, the first method for solving systems of equations, and you need to be good with both strategies. The first method is substitution. And substitution is going to be a good method if when you look at your equations, so I'm looking, for example, at these two, if you can find one of the terms that has the variable, so either the x or the y, and you notice that one of them just equals y, its coefficient is a nice 1. And in this case, I have two of them. They're both y. You can see I've got the same thing here. Also, little catch, if your handout doesn't have this as a positive 1/12, make sure you fix that. So what I did here, since both of these equations equal y, then I can set both of these things, both of these expressions then equal to each other. And now I'm back to what I did in the previous video. I see that, oh, I've got all these gross fractions here, so I can make them go away. I'm going to multiply by a 44 because that's going to be my least common denominator. When I distribute that 44 and I reduce along the way, remember 11 goes into 44 4 times, so then 4 times the negative 3 is negative 12. When I distribute that all the way through, notice I've got a much easier equation to work with here. And as I solve that, I get down to a nice x equals 7. Once I get that 7, I need to substitute that 7 back into one of these original equations. It doesn't matter which, but I need to substitute it into one of them to get the y value. I chose the first equation. When I substitute that 7 in and I work this out, I'm going to get, this is going to be a negative 21 over 11 plus a 54 over 11 is a 33 over 11, which of course reduces to 3. And I write my final answer as a 7/3. I've got another problem here. You might want to pause it and try to work that out and see if you can get down to this nice 14/8, okay? My other method for solving systems of equations is the method called elimination. Now, elimination is a method that a lot of students want to avoid, but is actually a really handy method to use when we look at all of our variables and we notice that all of them have different coefficients and none of them have a nice coefficient of 1. You're specifically looking for a coefficient of 1 if you want to use substitution from the previous example. Elimination is going to be used when none of those variables are a nice 1 or negative 1. So what we're going to do with the elimination strategy is we are going to try to get either the coefficients on the x's or the coefficients on the y's. It doesn't matter which. We're going to get either of them to be the same and opposite signs. Now, when I look at the y values here, what I notice, I've got them highlighted, what I noticed is that they're already opposite signs. One is positive, one is negative. That's pretty nice. So then what I'm going to do here is I just need to get their numbers to match. So I'm going to multiply the first equation by a 4 and the second equation by a 5. And when I multiply this whole first equation by a 4, distributing that all the way through, I get 16x minus 20y equals 68. When I take the second equation and I multiply it by 5 and I distribute it through, I now have 15x plus 20y equals 25. Now, when I look at these two, I notice that on my y's, they are now the same value but opposite signs. So if I add these two equations together, and the elimination method is sometimes called the addition method. Sometimes people call it the addition method because when we add these, the 16x and the 15x gives me 31x, but when I add these two, I get 0. They cancel out. And then I add the constants and I keep solving and I get an x. Now, just like before, once I have that x value, I need to substitute it back into one of the original equations, either one, to finish and get the y value. When I got over here to the second one, I noticed that the y values this time are actually already same signs, opposite coefficients. So I didn't have to do any multiplication. I could just add immediately and continue solving. Okay, now we're going to have a whole bunch more practice for this, and if you need any more help, let me know, and I can show you some more stuff or point you to some additional resources.